Okay, so we've got a set of data here, and it's all listed up as all of the variables with each variable's observations. So let's just label that up first. So all these rows, these are observations. So I'll just put that down for short. And these columns, these are all the variables. So I'll just put variables. And our goal is to find the sample covariance of y1 and y2. So for this part of the question, we're only going to be interested in these two columns. So these ones here, we're not going to be interested in for the moment. So sample covariance, how are we going to go about calculating that? Well, our first goal is going to be to find the mean. So let's find the mean of this and find the mean of this. So we're going to call this one column 1, this one column 2. So y bar of 1, that equals sum of all these divided by 6. So if we sum all these up, which I'd have done beforehand, we get 12,174. We're going to divide that by 6, and that will come to 2,029. So that's our mean average of this column. Now we want the mean average of this column. So if we sum all these up, we'll get 1,230 and divide that by 6. So now our mean average of this one, which we're now going to call y bar 2, equals 205. So y bar, the bar on the top, that denotes the mean average. And the 1 and the 2 will denote column 1, column 2, assigned to each of these variables. Okay, so next we need is the sample covariance formula. So that will look something like this, with S of A, B equals, so S stands for sample covariance, A and B, well that's column A and that will be column B. So in this case we've got column 1, column 2. So copying that underneath, we've got S1 and 2, so that will correspond with that. Then we've got 1 divided by n minus 1. Well, n is the number of variables, so we've got n equals 6. So n minus 1 will be 5. So now we've got 1 over 5. And we just move this across a little bit. I need a bit of space here. So right, n equals 6 here. Then that equals, we multiply this, the summation sign. So we need a summation from I equals 1 to n of y a I minus y bar and y b I minus y bar. And then that will correspond to the mean of A, this one to B. So now I'm going to put that under here, translating all the A's and the B's. So we've got n, I equals 1 to n, which is 5, sorry, which is 6, n is 6. So 1 to 6 of the I's, and then y, A is 1, and that's I, minus y bar of 1. So this is going to deal with column 1. And because it's covariance, we're going to multiply this now with y2i, so that's column 2, I, and then y bar b, so the mean average of column 2 in this case. Okay, so this would represent all of the observations, this will represent all of the mean averages. So now what we're going to do now is put the numbers in and crunch them together. So S12, our sample covariance, 1/5, and now we need a big, I'll do a nice big square bracket, and now we're going to go through all the numbers up to 6. So we've got yi, 1y, 1i, that's 2145, minus y1, which is 2029, multiplied by y2i, which is 185, minus the average, which is 205. And then we're going to add that so on with all the columns as we go along. So that's the first column. Now the second column, 2002 minus 2029 times 214 minus 205. And then add that with the next one, number 3, 1987 minus 2029, and multiply that by 235 minus 205. And we're still in, we're going to continue it here. Fourth one, 1970 minus 2029, 202 minus 205, and the next observation, 2045 minus 2029, again the average, multiplied by 194 minus 205, and then add that on to the last observation, which is 2025 minus 2029, and then the last one is 200 minus 205, and then big bracket. Okay, so now it's just basically a question of just translating all these calculations and just simplifying up. So now we've got this equals 1/5, and now go through each one. So the difference here is 116. Difference here is minus 20. Difference here is minus 27. This one here is 9. 1987 minus 2029, that's going to be minus 42. And then the next one, 235 minus 205, that's positive 30. This one here, minus 59. And 202 minus 205, minus 3. 2045 minus 2029, that's 16. And this one here, minus 11. And finally this one here, minus 4 and minus 5. Okay, now get the calculator out now. 1/5. Right, 116 times minus 20. Minus 2320. And then we're going to add onto that. Minus 27 times 9, well that's minus 243, that's fine. This one here, minus 42 times 30. 342 is 126, that's minus 1260. Plus minus 59 times minus 3, well that should be 177. 16 times minus 11, that's going to be minus 176. And then plus minus 4 times minus 5, that's plus 20. Okay, now let's add all these up. So we got minus 2,320. So let's do that. That's minus 243. Minus 1260. Plus 177. Minus 176. Plus 20. So that equals minus 3,820. So that's minus 3820 over 5. Okay, so minus 3820 divided by 5, that becomes minus 764. So this equals the covariance between 1 and 2. So covariance 1 and 2. So basically what that means is we've got a minus number in here. So minus 764. That would mean that these two variables here are inversely related. So we can just translate that as maybe in finance terms, that when this one is high, this one might be low. and conversely the same. When this one is low, this one might be higher. When it says higher, as in higher than the mean or lower than the mean. So there we go. Any more videos you want to be interested in with covariance and means and all that kind of stuff, check the link below, and there'll be plenty of links in there for you to follow. Thank you very much.